Alright guys, this lesson is about rate of change, and we'll be doing some applications. In other words, some real world problems, word problems. Now, rate of change, you remember, is the same thing as slope. Okay, rate of change will be calculated just like slope, y2 minus y1 over x2 minus x1. We just need to figure out which are the x values and which are the y values involved. Now here's one hint to help you. X values, anytime time is involved, time is always x. So that makes it easy on problems like number 32. Because right away we see in 1960 the population of Detroit, Michigan was 1,600,000. But 1960 is a time. So you know that is going to be an x value. So we'll call that x1. Let's go ahead and do the other one. We see that in 2012 the population was 707,000. Well, that's a year, so another time. So that'll be x2. So those will go in the bottom in a minute. That means these other values must be our y values. So the population is the y value. So we will call this population y1, and we'll call this population y2. Do not forget the units. Okay, let's go ahead and discuss the units a little bit right now. We mentioned that the population will be the y values. When we're talking about population, we are talking about people. Okay, so people are the units that will be in the numerator for the y values. And in the denominator, we have years. So in the denominator, the units will be years or year. So we're talking about people per year. So in this case, the population, you can see it's decreasing, okay, from 1,600,000 to just over 700,000. It's decreasing. So we're going to figure out it's decreasing by how many people per year. So your units are very important. So let's go ahead and do the calculations. So if we're going to do y2 minus y1 in the top. So like we decided, y2 is going to be our 707,000 minus y1, which is 1,600,000. Okay, so there's our y2 minus y1 over, and now we'll have x2 minus x1. So this will be 2012 minus 1960. Okay, let's figure out what this is. I would recommend, this would be a good time to just go ahead and use our good old TI-30 XS Multiview. Okay, so hit your fraction key, and we'll do 707,000 minus 1,600,000 over 2012 minus 1960. And hit enter. Okay, so there we have it. Minus 17,173. I'm going to just round it to the nearest person. Alright, it makes sense because you can't have fractions of a person. Okay, and again, let's include these units very carefully. Okay, as we say, negative 17,173 people per year. All right? Now, what does this negative sign mean? This negative means that the population is decreasing. This means that every year that goes by, on average, the population is decreasing by 173,000 people. So, if we started in 1960 with 1,600,000 people, it's like every year doing minus 17,173, minus another 17,173 each year until you get down to this amount. So the minus means that the population is decreasing. If the population had been increasing, this would have been a positive number. But anyway, this is the answer to number 32. Please do not leave off the units. Any real world problem, you got to have the units. All right, and number 33. This one's going to be a little trickier because it doesn't involve time, so it's less obvious which should be the x values and which should be the y values. Let's see, after 5 seconds, well, that's time. Never mind, that is time. So 5 seconds, so you can, time is always x value. So that 5 seconds, that's my x1. Okay, and a car had accelerated to 16 miles per hour. That's y1. After 10 seconds, that's time again, so that'll be x2. Okay, now let me go back and catch those y's. All right, so after 5 seconds, the car had accelerated to 60 miles per hour. Okay, so that's y1. After 10 seconds, the car had accelerated to 80 miles per hour. So that's y2. Of course, the rate of change is calculated just like the slope. y2 minus y1 divided by x2 minus x1. Okay, so in this case, that means, okay, y2, so that's 80 miles per hour minus y1, which is 60 miles per hour, over, now we'll do the x's, x2 minus x1. So 10 seconds, okay, minus 5 seconds. All right, now let's keep an eye on the units. Let's go ahead and talk about the units right now. In the top, we have seconds. No, the top is not seconds. In the top, we have, well, in the top, we have miles per hour. So this will be a slightly complicated expression, but we have miles per hour. And in the bottom, we just have seconds, all right, because the x values were in seconds. So it's going to be miles per hour per second, okay, because we're talking about the change in speed. All right, so will the speed be increasing by a certain number of miles per hour each second, or will it be decreasing? All right, so miles per hour in the top and seconds in the bottom. So there's our units. So we should be able to calculate this pretty easily. So 60 minus 80 is 20. All right, 10 minus 5 is 5. Okay, so it's all positive. And 20 divided by 5 is 4. And please do not forget your units. So the rate of change of the speed of this car is 4 miles per hour per second. Okay, and please understand that that means that the speed of the car is increasing over time at a rate of 4 miles per hour each second. In other words, every second that goes by, the car is moving an extra 4 miles per hour. All right, so if we were looking at seconds, all right, I'm going to put time and then miles per hour. Right at the beginning, we had, well, okay, I guess it said after 5 seconds. After 5 seconds, the car was going 60 miles per hour. Okay, so if it increased at a constant rate, I mean, this is the average rate, but the idea would be after 6 seconds, all right, this is seconds, so 5 seconds we have 60 miles per hour. 6 seconds, it would be 64 miles per hour, okay, because it's increasing 4 miles per hour each second. After 7 seconds, we should be looking at 68 miles per hour. So I just wanted you to get a feel for what this means. We're talking about a rate of change. We're talking about how fast the speed is changing. All right, that is it for this video. I hope it was helpful. I hope you have a better grasp on the meaning of rate of change, and I will see you on the next video. Don't forget your units.